Welcome friends to my YouTube channel CyberiLabs. So in this lecture we will continue the OSI reference model part 2 where I will explain this transport layer in detail. Because I made this video separately for the transport layer, the reason why, because transport layer is one of the most important layer of this OSI reference model and I want to explain this layer in detail. So let's start without wasting time. So transport layer basically responsible for five important functionalities. Okay, so on at transport layer we can say five major functions occurs. So first one is delivery of data. Delivery of data. Second one is your segmentation. Segmentation. Third one is multiplexing. Okay, fourth one is flow control. And the last one, fifth one, that is connection management, which is pretty much similar to the session layer functionality, but we will take a look like what's the basic difference in the functionality. In comparison, we will compare the functionality of session layer and transport layer in regards of connection management. So delivery of data. So first we will discuss this. So delivery of data, while like taking decision how we want to deliver the data, we have two options to take this. So first option is if our priority is speed, in that case I will use the UDP protocol, and if my priority is reliability, in that case I will use TCP protocol. So I will explain this UDP and TCP first, then I will show you like how this TCP providing reliability and why this UDP protocol is faster than your TCP protocol. So this is the, you can say, best practice over the delivery of data. If your recommendation is speed, go for UDP. If your recommendation is reliability, go for TCP. So now we will go for TCP and UDP in more detail. So for TCP and UDP, TCP is transmission control protocol, alright, and UDP is user datagram protocol. So first point for the TCP is TCP protocol number. TCP protocol number is 6, UDP protocol number is 17, and this is the predefined protocol number. So it's not like TCP protocol number changes, it is fixed, it is predefined by the international organizations. So these numbers are already assigned to these protocols. Second, the TCP header size. TCP header size is 20 bytes, okay, and the UDP header size is of 8 bytes. So if someone asks you like what is the size of TCP header, you can say 20 bytes and UDP 8 bytes. But if he asks you like is it fixed, so in that case you can say it can reaches up to 60 byte. So it can vary between 20 to 60. Okay, minimum 20, maximum 60. But in the case of UDP there is no such option, it is fixed, it is 8. Alright guys, then third point about this TCP protocol is it is slow. This UDP protocol in comparison to the TCP protocol, it is fast. Alright, now fourth point, TCP protocol is reliable, whereas this UDP protocol is unreliable. Now next point, TCP is connection oriented. TCP is connection oriented, but whereas UDP is connection less. Next point, TCP is synchronized. It is sequenced protocol. Take care of each connections, but whereas in UDP there is no synchronization, no sequence. Alright, so these are the main and important differences between the TCP and UDP, and even you can explain these protocol individually. If somebody asks what is TCP is all about, you can say these 5 points and you can explain these 5 points. So if you like I need to explore more because these 2 points are self-explanatory, but these 4 points I want to explain you like how TCP works. If you know that how TCP works, you can easily identify that this is the reason why TCP is slow and it is reliable, connection oriented and sequence. And if you know that how UDP works, you will easily identify that why this UDP protocol is fast, unreliable, connectionless, and non-sequenced. Alright, so we will see how TCP and UDP works. So working process will tell us each and everything about TCP. So move to the next point. The next point is TCP, how TCP works. So TCP, let's suppose if you are using TCP protocol to establish a connection, let's suppose this is your PC and this is your web server, any web server, any website, let's suppose it is Google. Okay, so let's suppose this PC, in URL bar you typed google.com. so now you are establishing a TCP based connection. Okay, so in TCP based connection, first before getting that web page on your screen, TCP goes through a process we call it three-way handshake. Three-way handshake. Alright, so three-way handshake process is about this client will forwards a message, we call it SYN. Okay, in response to this SYN, this server responds back with an ACK. This is an acknowledgement of this SYN and as well as its own SYN. Okay, the server also sends its own SYN and it acknowledges the SYN of client, and in response of this, client acknowledges the SYN of server. This SYN acknowledged by client, and after this three-way handshake, your connection will established. Okay, so if you have a just have a look and see, before getting a web page, this three-way handshake process comes with the picture. Because of this three-way handshake, your TCP protocol is slow. You are getting an acknowledgement for each communication. Let's suppose you are forwarding a SYN, you are getting an acknowledgement. You are forwarding a SYN, you are getting an acknowledgement. Because of this acknowledgement, because of you are acknowledging each and every thing in communication, during communication, that's the reason why this protocol is reliable. Okay, now connection oriented. Why this TCP is connection oriented and sequence? Because it takes care of its connection. Why I am saying this? Because if you see this SYN is not like a single information. This SYN consists of a multiple information. You can say SYN tells each and everything about this client to this server, because these two identities, client and server, this client and server negotiating their parameters during this three-way handshake, because after negotiation of these parameters only they can decide whether they are okay with this connection or not. Alright, so this SYN consists of many parameters, but for the sake of this three-way handshake, I will explain you the one thing, which is ISN, that is initial sequence number. This initial sequence number is a random value selected by this PC. Okay, selected by this PC and acknowledged by my server. So why this PC selects a random value that we call it ISN? Because let's suppose if you are establishing multiple connection, this is for Google, this is for Gmail, this is for Yahoo. So if you see this single PC establishing a connection with multiple servers. So in this case, if let's suppose this Google, Gmail and Yahoo responding to this SYN of this client, how this client will identify that whether this is a acknowledgement of a Google, or this is an acknowledgement from the Google, Gmail, or from a Yahoo. Why? Because in SYN it takes this value, ISN value. Let's suppose for the Google it uses 50, for Gmail it uses 100, and for Yahoo it uses 200. So what will happen? Let's suppose in response from the Google, this value will be incremented by 1, that will become 51. In response from the Gmail, it will be 101, and in response from the Yahoo, this will become 201. So by this PC can easily identify that from which server I am getting this response. Alright, so this is the role of ISN. So this is how this TCP three-way handshake happens, and because of this three-way handshake, this protocol is slow, reliable, sequence and connection oriented. Now check out one thing. There is one more handshake, we call it four-way handshake. Four-way handshake. and we also call it this four-way handshake, gracefully TCP shutdown. So this is a proper mechanism, a proper handshake to shut down your TCP based connection. Okay, why it is so? Because this is a reliable connection. Why reliable connection? I already discussed that, during this three-way handshake, these two client and server sharing their information, negotiating their parameters. So anybody, man in the middle can hijack this session, by hijacking its all identity, and can establish a connection with this server, and after spoofing the identity of this PC or client, this man in the middle can establish a connection with this Google server, and let's suppose whatever the malicious activity it does, the blame will be on this PC, because this attacker is using an identity of this reliable PC. Okay, so if you want to avoid these type of stuffs, okay, if you want to mitigate these attacks, in that case we have four-way handshake mechanism in TCP. It means that you need to shut down or close down your reliable connection TCP. So in this client will forward a FIN. In response to the FIN, this server sends ACK, okay, and its own FIN, and in response of this FIN, this client will forward its acknowledgement. Alright, so in this four-way handshake, what is happening? This client forwards a FIN. It says like, I want to finish this session. Server acknowledge this. Okay, I'm okay with that. I also want to finish this session. And in the same way, this client will response back with the acknowledgement that just terminate this connection. After this four-way handshake, this TCP handshake or TCP connection is shut down. Okay, now if you compare it with UDP working is very simple. Okay, very simple in comparison to TCP. In UDP there are only three messages: query and reply and update. Okay, so let's suppose this is a client, this is a server, and this client wants something from this server. So this client can directly request to this UDP and ask with the query message, and in response of this query message, the server responds back with an answer. We call it reply. Okay, there are few situations where server update this PC regarding some information. Let's suppose if there is any update on the server side and the server wants to inform its client, in that case this server can forward an update message. Otherwise there is no such situation where this update messages is used. So normally the communication of UDP is like forwards a query and response to that server forwards a reply. The flow of query is from client to server, flow of reply is from server to client, and flow of update messages from server to client. So this is all about UDP. This is how UDP works. So if you compare it with the TCP, you can easily find out that why this UDP is faster, non-reliable, and non-sequence and connectionless. So this is, you can say, basic difference between the TCP and UDP working mechanism. Alright, we will discuss later where we use TCP and where we use UDP in real environment. Okay, I will explain that in some classes, like in future I will discuss all those protocol in detail, like TCP, UDP, HTTP, HTTPS and SSL. So I will explain that thing. Okay, where we use or where we prefer UDP and where we prefer TCP. But for the transport layer, this is done for the TCP and UDP. So first functionality, delivery of data is over. Second is segmentation. Segmentation is something where you are breaking down some bigger thing into smaller chunks. Why? To reduce the complexity. So let's suppose some big packet is there, okay, which is not under the capacity of a device to process. So what we do, let's suppose this is a bigger packet, we break down into smaller chunks. Okay, so that we can get into this bigger packet into pieces, and we can easily work out on those pieces, because it is very easy to process smaller packets in comparison to the bigger packets, and it is very easy to understand those smaller chunks. Okay, so concept of segmentation is to break down bigger thing into smaller chunks. Concept. And the same concept is fragmentation is also there. Why I am including this fragmentation? Because normally this fragmentation is a part of network layer, but I want to cover it here only. Why? Because segmentation and fragmentation both are same with the result wise. If you see, the motive of the fragmentation as well as segmentation is same. Fragmentation occurs at layer 3 and this occurs at layer 4. So I will discuss these differences, but now I will tell you the motive of segmentation and fragmentation is same. The motive is to break down bigger thing into smaller chunks. Now the differences are, it works at layer 4, it works at layer 3, it works it is software based, it is hardware based. In some book it is written like that, it is logical, it is physical. All right. And the third point is about your, on the basis of MSS. Segmentation occurs with in regards of MSS, maximum segment size, whereas fragmentation occurs with respect to MTU, maximum transmission unit. On the basis of MTU, fragmentation occurs. On the basis of MSS, segmentation occurs. Okay. So what is MSS and MTU? I will tell you and I will explain you this. And MSS I will explain you in TCP header class. Okay. And MTU I will explain you right now. MTU is maximum transmission unit. The maximum transmission unit is 1500 bytes. 1500 bytes. It means that as per networking fundamental, no packet greater than 1500 bytes is allowed to through the network. Okay, if any packet size is more than 1500 bytes, this packet is not allowed. In that case, we need to perform the fragmentation. First thing, this is the default size, we can say this is a default size of MTU, maximum transmission unit. I told you that this is a hardware concept, this is a physical concept. We can modify, we can customize this size as per our requirement. Remember this. Okay, we can customize this MTU as per our requirement. Let's suppose this is your core router, and from internet you don't want to allow any packet whose size is greater than 400 bytes. It is possible. On this interface you can enter a permit or create a policy where you can define that there is no such packet whose size is greater than 400 bytes is allowed into my network. Alright, so this is the thing. MTU is a like a physical concept where you can modify your MTU on the basis of your requirement. So this is all about segmentation and fragmentation. Third one is multiplexing. Multiplexing is very simple. Let's suppose this is a PC. It has its IP, but with a single IP, this PC also accessing Google, Gmail, Yahoo, YouTube, and other social media sites. So multiple connection. If you are establishing multiple connection with a single source IP, that is multiplexing. Alright guys, so this is a very simple example and we can easily understand that what is multiplexing is all about. Now fourth one is your flow control. Okay, so I will explain you flow control from the legacy method. Okay, first I will discuss the classical method, that is ready or not ready. Okay, after ready or not ready, one more method was introduced by those R&D department, that is windowing. After windowing, there is one more concept introduced, which is a current scenario. Nowadays we use this concept, we call it sliding window. So I will explain all those three things. So first I will discuss ready and not ready. So before explaining this ready or not ready or windowing and sliding window, I want to discuss one thing, that is about units. Okay, so to calculate anything, let's suppose if you are calculating weight, okay, you are calculating your height, you're calculating the length. So we have units to calculate that. We can calculate in centimeters, meters and inches. Alright, So same way to calculate the data. To calculate the data, we have units uh, in our networking. So to calculate the data or datagram or payload, what are the units are? We call it PDUs, protocol datagram units. Protocol datagram units. So on top three layers, layer 7, 6 and 5, the data is known as data. Okay, other word is payload and other word is datagram. So these are all synonyms of data only. Okay, don't get confused with the keywords payload, datagram and data. Okay, so these are the words interchangeable uh, for on the basis of requirement and on the basis of like what kind of a book we are reading, and they use a word on the basis of their theory, but it's like these three words are totally synonym of each other. So now see this layer 4. On layer 4 we call it segment. The data is known as segment. At layer 3 we call it packet. At layer 2 we call it frame, and at layer 1 we call it bits. You got my point? To calculate data we have these different types of units. Okay, so if I say segment is lost, so obviously my data lost at layer 4. How descriptive this OSI reference model is, how effective this OSI reference model is. Even by saying this, my segment is lost, we can easily identify that this is the problem of layer 4. Okay, if I say my packet is lost, I can easily say if my packet is lost, this is an issue from the related to network layer. Okay, so this is how we can easily identify by the name only that where is data exactly located. This is the reason there is a single definition for OSI reference model. For OSI reference model there is one liner. We call it defines data packet flow. It defines data packet flow. Okay, so this is a single line definition. If someone asks you like what is OSI layer, in one line can you explain that? You can say simply like it defines the data packet flow. That's it. Now back to the ready to not ready. Ready not ready was very simple and easy way to communicate to each other. So this is, let's suppose, sender and this is receiver. This sender forwards a segment 1. So this receiver receives a segment 1 and start processing. Meanwhile this sender sends one more segment. So this PC is busy with this S1, as segment 1. So what this PC will do, this PC put this segment 2 into a buffer. So now this segment 2 is in buffer. Let's suppose, assume that this buffer size is of only for one segment. The maximum segment this buffer can store is for one segment. In the meanwhile, when this buffer was full, this PC sent segment 3. Alright, so what will happen? This PC busy with S1, buffer is full. In that case, this segment 3 is lost. So we don't want any loss of packets. Nobody in its communication wants to lose his packets. So to protect this, okay, we introduce this so that we can protect our overflow of packets or overflow of segments. Okay, so to protect overflow, we introduce this flow control, and in flow control, ready or not ready was the first step to do so. So first step, what happens? Let's suppose this buffer is full. Now this destination responsibility is to inform this client that my buffer is full by telling not ready. So when this sender receives this not ready, this sender will wait for ready signal. After receiving ready, this sender will again starts forwarding segment. Okay, there was no issue with the ready or not ready, but there were few demerits or limitation with this ready or not ready. First limitation was delay. There was a delay. Okay, in real time, if you compare it with this milliseconds of delay, there is big for any network. Okay, so for real-time traffic, especially this ready or not ready was not working fine. If I say word real-time, it means that the traffic which works in live environment. Let's suppose if we are communicating on a phone, let's suppose if we are using a voice over IP phone, and if we are working communicating, or we are in a video conferencing over the internet, if I say hello and you are receiving that hello after 10 seconds, so this communication doesn't make any sense, because you are losing your packets, you are losing your segments because of delay over the internet. All right, so delay was the issue with ready or not ready. Second was, our motive was that time to achieve 0% loss. We don't want to lose any packet or any segment over the communication, so that was our goal, so which was not achievable with the help of ready or not ready. Now, after this ready or not ready, second step was taken, and the second step was windowing. Okay, windowing with a very simple concept. You are a sender, it is a receiver. The sender will forward a segment, and receiver responsibility to acknowledge at the moment. Okay, so once you receive the segment, acknowledge this. Same way you forward the segment to, you receive an acknowledgement. Okay, so this is very simple. If you see, our motive was 0% packet loss. We achieved it with the help of windowing. We achieved this goal where we were not losing any packets or any segment, because after sending this segment, if I receive an acknowledgement, then only I am forwarding my segment to. It's not like that I am not waiting for this acknowledgement and I am directly forwarding the segment to. Alright, so we achieved this. Okay, but what was the problem, or what was the limitation with this windowing was, the bandwidth consumption was very high. Bandwidth consumption was very high. Why it is so? If you see, there are lot of acknowledgement traffic. There are lot of acknowledgement traffic. For each segment, we are using an individual acknowledgement. Okay, because of this, we were consuming lot of bandwidth. So solution for that was dynamic windowing. Dynamic window. So solution was dynamic window. So what is this? So let's suppose this is a sender and this is a destination. Okay, so in the case of communication where we try to select our window, so for this, or in this case, understand this like this. Let's suppose you are forwarding 3 segments, okay, to this destination, and in response of that you are getting a one acknowledgement. All right, so how it is possible? This communication is possible only when during three-way handshake, this sender and this destination or receiver, whatever you want to say, negotiate that this receiver will tell this sender, you can send me 3 segments in one shot, or simultaneously you can forward me in 3 segments. Okay, so in one window you can put 3 segments. I am capable for that. You can forward me 3 segments in one window. So during three-way handshake, this receiver tells the sender about its window size. Window size. Remember this word, window size. During three-way handshake, this receiver tells the sender about its window size. After negotiating the window size, the sender will forward segment and decides on the basis of window. Whatever the window size was negotiated during the three-way handshake, it will include those number of segments into that single window. After receiving those segments, this receiver forwards an acknowledgement. Let's suppose if window size is of 3 segments, I am forwarding 3 segments. Alright, so in response of that, I am getting one acknowledgement. Okay, so it is dynamic. Okay, automatically they are negotiating, automatically they are exchanging this information that I am capable with this number of segments in a single window. Alright, so let's suppose in first communication he was okay with the 3 segment. Okay, So now this receiver is free, or maybe this capacity of this receiver increases, so it can negotiate during the communication only. This receiver can tell the sender, now I'm okay with this 5 segment. Okay, so in next window please send me those 5 segments. Okay, so after sending those 5 segments, this receiver can acknowledge, okay, I received those 5 segments. Now what's a click over here? Let's suppose this sender forwards 3 segments to you, okay, and you received first and second, but you didn't receive this second segment. So in that case, this responder responds back with an acknowledgement plus info about lost segment. Okay, so in next window, the number of segment, first segment will be second, lost segment, and followed by next segment. Lost segment followed by next segment, and size will remain same. If you lost something, okay, and you inform the sender that I lost something, please repeat that segment again and acknowledge other segment. In that case, on the basis of window size, you will forward the lost segment plus the next segment. So this is all about windowing or dynamic window, and we call it this dynamic window mechanism sliding window. See, to understand the sliding window, there is one more concept of marking and unmark. Okay, mark and unmark. But for the beginner, this is not the right situation to discuss that marking and unmarking. Maybe I can discuss in some bonus video or like some advanced topic of TCP header. But right now in OSI reference model, I don't think so it's a right choice to discuss sliding window with the marking and unmarking concept. Alright, so for this you need to understand ready or not ready for the flow control, windowing and sliding window. Alright, so now the last one is, fifth one is connection management. So to understand connection management, it is very simple. The connection management is responsible for the initiation, maintenance and tear down of a connection. So session layer is responsible for providing notification only. Session layer is responsible for this connection management only for notification. This session layer only provides notification that your connection started. This much times are spent during this connection, and at this time this connection was log out. But actual decision, actual mechanism of this connection management occurs at transport layer. So decision of connection initiation taken at transport layer, okay, and log out and how long that connection was, everything maintained by transport layer. Decision making. Okay, so if you want to take an example, we can take an example of a one football match, let's suppose. Okay, one football match of 1 hour, 4 quarters are there of 15 minutes, and each quarter you can take 2 timeouts of 1 minutes. Okay, so there is a coach, there is a referee, and there are the team players. So match starts at 12 o'clock. Let's suppose this coach decided that I want a timeout at 12:10. So this coach informs the referee and referee informs the players. So this referee part is a session layer, because this referee providing a notification to the players that your timeout starts now. But actual decision of taking timeout was taken by coach. So I hope this is more than enough to understand the connection management and OSI reference model, and especially this transport layer. And I will discuss those last 3 layers in a separate video. Okay, so I hope this video is informative for you guys. Please like, share and subscribe this channel, and bye bye, take care.